All right, everybody. So we are back to learning about the quadratics and using the quadratic function. The quadratic function is the function that is the start of physics. It's used for measuring projectiles and things that are in motion. So for those of you who are the future engineers of America, or if you want to have some field in science or physics, the quadratic function and the parabola are the start of learning how to measure and model things that are in motion. So as we start today, here's our scenario for today. It says here, Marcus hit the baseball with an initial velocity of 70 feet per second. He made contact with the baseball bat when it was 3 feet above the ground. Okay, so what it says here is there's 4 questions we're going to try and answer. The first one is, it says to write an equation to represent the height y of the baseball x seconds after it is hit. So if I'm going to write that equation, the way I'm going to write it is y equals, and go ahead and do this with me, please, on your own slide. We're going to do y equals. Now, whenever we're dealing with gravity, there are certain constants of gravity that we use based on the scenario. So for this one, our constant for gravity is going to be negative 16, okay? And the reason it's negative 16 is because gravity, as we know, pulls things down. So as this baseball flies through the air, unless he's hit a grounder and it just bounces along the ground, it's going against the force of gravity. So the constant we use for gravity here is a negative 16. So we begin with y equals a negative 16x squared. Now, velocity is 70x, and then it was 3 feet above the ground. So that's how we write that function. This parabolic function, this quadratic, would be negative 16x squared plus 70x plus 3. So question number 2 says, at what time will the baseball reach its maximum height? Well, we already know that since this is a negative number here, that this parabola is opening downward. So we're dealing with the maximum. So if we're looking for the time that the baseball will reach its maximum height, time is the x value. Y is the height. Time is x, or the seconds after the ball is hit. So since we're looking for x, what you want to use is what we learned last Thursday and what you practiced yesterday, is to find the x value, which is going to be your axis of symmetry. So go to that, and you can pause the video right now if you like. I'm going to work it out on a piece of paper as well, and we'll come back and see what we got for x. Okay, so for those of you who stayed with me, what we're going to do is I taught you how to find the x value, or the axis of symmetry. So x equals, and it equals a negative b over 2a. So if I look at this particular equation that I have here, okay, and I'm trying to solve for x, all right, I'm trying to solve for x here. So my b value is a negative 70, because b is 70, so a negative b would be a negative 70. And then all of that is over 2 times a negative 16, because that would be my a value. Okay? So as I continue to work this out, I have x equals, that's going to be negative 70. And then 2 times a negative 16 is a negative 32. So that means x here is going to equal, so negative 70 divided by negative 32 is going to give me 2.1875, which, let's go ahead for our purposes today, we're going to round to the 100th position, so we're going to have 2.19. Okay? So if I go back over here, and for those of you who are back with me, my x value is 2.19. So what that basically means is that after 2.9 seconds, the baseball will reach its maximum height. Okay? So after 2.19 seconds, the baseball will reach its maximum height. Okay? So that's the answer to number 2. So then now the answer to number 3, or the answer to 3 says, what is the maximum height of the ball? So if we know that the baseball is going to be the maximum height after 2.19 seconds, then what I'm going to do next is take that 2.19 and substitute it for x and back into this equation here. Okay? So what I'm going to do then is I'm going to take that equation, which is y equals a negative 16x squared plus 70x plus 3, is I'm going to take this equation, and every place I have an x, I'm just going to insert the 2.18. Okay, so y is going to equal a negative 16 times 2.1, or excuse me, that's supposed to be 2.19, I'm sorry. And then raised to the second power plus 70 times 2.19 plus 3. Okay. So then on my next line, again, so y equals, so 2.19 squared, so if I do that on my calculator, I get an answer of negative 16 times 4.7961, which I said that we would go ahead and round everything to the 100th power, so this would just become 4.80. Plus, and then 70 times 2.19 comes out to 153.3 plus 3. All right, so when I do this math, so the negative 16 times 4.8 gives me negative 76.8 plus 153.3 plus 3. So now I perform this mathematical operation. So my answer then becomes 79.5. Okay, so what I just found is the height, the maximum height, or how high the ball is going to be when it's traveled its maximum, when it's traveled 2.19 seconds. So the height of the ball will be 79.5 feet is the maximum height of the ball. Okay, so my next question is, when will the ball hit the ground? Okay, so what we're going to learn is something new today about how we're going to determine when the ball is going to hit the ground. Okay, and this that we're going to use to solve this is called the quadratic formula. So what I want all of you to do is make sure you have a separate sheet of paper so you can write this down, because you're going to need these notes for today and for tomorrow. So I'm going to pause for a moment while you get some paper ready so we can do this, okay? All right, so I'm going to go over here to Desmos now real quick. And so here we have a parabola that is opening downward, And it's a good model of what a baseball looks like when it's hit into the air. It starts at a certain point, it goes up, and then it goes back down. And so what we're looking for on question number 4, which says to us, when will the ball hit the ground, is we're looking for what we call the zeros of the function, or where the function would, in theory, begin and end. So in the case of a baseball, we would start at a certain level, and then we would end when it hits back here on the ground. So this is what we're looking for, are these two values right here and right here on our parabola. So those are what we call the zeros of a function, or the factors of a parabola, or the roots of the function. Okay? So if we start with our quadratic formula, or the equation that we've been using, what we've been using is y equals a negative 16x squared plus 70x plus 3. Okay, so that's the equation that we've been using. So what we're going to use is what we call the quadratic formula to find out what the x values are, because this does not factor very easily. Okay, trying to find two numbers that when added together and multiplied by each other would equal 3, as well as 70 and negative 16 is in there, is quite a task. And we can't do that by normal factoring, but we can do it by using the quadratic equation. So the first thing that we're going to do is we're going to take this equation and we're going to plug it into the following. So here's what I want you to write on your paper. Is it's going to be a negative b, and then we have our symbol here, the plus or minus symbol, and then we're going to write the square root of b squared, or b raised to the second power, minus 4ac, and all of that's going to be divided by 2a. So negative b plus or minus b squared minus 4ac over 2a. So we need to remember now, when I have any kind of a quadratic function, this is my a value right here, this is my b value right here, and this is my c value right here. So all we're going to do is substitute all of these numbers into this formula that I've given you, and we're going to solve it to find out the points where the baseball would be hitting the ground. So here we go. Now, this is a little bit of work, and I will say right now, for those of you that do not like to show me your steps, you are really going to struggle with this, because there are so many moving parts that if you're not showing your steps and you make a mistake, it's going to be very hard for you to find where you made that mistake. Okay? So you really need to, if you're not now in the habit of showing your steps, you need to get in the habit of showing your steps, because we're at the point of math where you cannot live without showing your steps. Okay, so there I did. I substituted all of my numbers into this formula. So negative b, 70 is b, plus or minus the b squared, which is 70 squared, minus 4 times a, which is my negative 16, times c, which is my 3, all divided by 2a. Okay, so let's just go ahead and start doing some math. So it's very important that we remember our order of operations as we do this. Order of operations is always important. So I have negative 70, and then I've got plus or minus, and the square root. So 70 squared is going to be 4,900 minus, so and I have here 4 times a negative 16 times 3. So 4 times negative 16 times 3 on my calculator gives me a negative 192. Okay. And then all of that's going to be divided by a negative 32, because 2 times a negative 16 is a negative 32. All right, so then for my next step, so I'm going to have negative 70, and then, again, plus or minus. Now, when I look here, what's inside my radical, I have 4,900. So negative, two negatives make a positive. So I have plus 192 divided by negative 32. So this is going to be 4,900 plus 192, so it's going to be 5,092. And then all of that divided by negative 32. Now, what I'm going to do is I'm going to find the square root of 5,092 on my calculator. So I've been told that the TI-83 was pushed onto your Chromebooks as an app. I don't know if it has been, or I've not seen it. I don't know how well it works or not, but I'm going to try and see what I can figure out about it. And we'll probably start using that calculator next week once I can get more information on it. Okay, so now, when you get to this point in your quadratic formula, I have a negative 70 plus or minus 71.35. So what I have now is two equations, okay, because of the plus or minus symbol / operation, I have two equations to solve. Okay, so one of the equations is going to be a negative 70 plus (71.35). I need to make that a fraction. Bear with me. So I'm going to have a negative 70 plus 71.35 divided by a negative 32. That's going to be one equation. Okay. And my other equation is going to be, because I also have a minus there, so my other equation is going to be negative 70 minus 71.35 divided by a negative 32. Okay, so what I need to do now is I need to solve both of these equations. So if I solve the first one over here, negative 70 plus 71.35 divided by 2, is going to give me 1.3. Whoops, need to make that a fraction again. It's going to be 101.35 over 2. Okay. And then negative 70 minus, should be in, all right, so then negative 70 minus 71.35 is going to be a negative 141 and 35 hundredths divided by negative 32. Okay, so this answer here equals I'm doing it on my calculator. And negative since I said we would round to the 100th for this assignment. And then this one's going to equal okay, because two negatives make a positive. All right, so what I have now is I have two answers. I have one answer is a negative 0.042. My other answer is 4.42. So what I just found, everybody, are what we call the zeros of the functions or the x-intercepts. So on a parabola, it's going to be these two numbers right here that I just found. Okay, these are going to be the two numbers that I just found. So if you picture this as a baseball, it left the air and here's where it's going to hit the ground. So this is the number that I want to find. So if you look at both of these numbers, the correct answer would be 4.42. So when we look at the question that says, when will the ball hit the ground? The ball is going to hit the ground after 4.42 seconds. Okay? So I'd come over here. When will the ball hit the ground? After 4.42 seconds. Okay? So the reason we went through all that work is because this does not factor evenly or easily for us. So we had to use what we call the quadratic formula to find the answer there. All right, so then if we went a step further and came over here to Desmos, we could actually graph this parabola, which is y equals negative 16x squared plus 70x plus 3. And if I zoom out just a little bit, this is what we just did. Okay? We found out that my parabola is going to cross the x-axis here at negative 0.42, negative 0.0420, and it's also going to cross at 4.41. So those zeros of the functions tell me that when I hit this baseball, that it's going to go up in the air. It's going to start here at 3 feet in the air. It's going to go up, and that's about what we came up with was 79.5, and then it's going to land on the ground after 4.4 seconds. Okay, so that's what we just solved. So I know you might be saying now, well, why can't I just use Desmos all the time? Well, because you're not always going to have Desmos at your disposal to use all the time. So we have to know how to use the quadratic formula, because the quadratic formula also opens the doors to lots of other things in math that you're going to be learning. Okay? So what I want you to do next is on the next slide, there are 4 quadratic functions, and I want each of you to solve these quadratic functions using the quadratic formula that I just showed you. So for those of you who would like to work on your own, you can go ahead and get started. I will do the first 2 of these continuing on this video for those who would like to stay with me and do some more practice with me. And then if you need more help, we can come up on Google Meet. So I will see everybody tomorrow again. Have a good day. And I'm going to pause right now, and then I'll be back in a moment to work out the first 2 down here for those who want to stay with me. Okay, so another way of writing a quadratic function when we are solving it for the zeros of the function is to set that function equal to 0. So what we're going to do then is we're going to do x raised to the second, whoops, why didn't that do, oh, I know why. All right, x raised to the second power plus 8x plus 15 equals 0. So this is the way we can write a quadratic function when we are trying to solve for the zeros of a function. Okay, So the next thing that I'm going to do is go to my equation that I have, which is the negative b, and then we're going to have plus or minus, and then the square root of b squared minus 4ac, and then all of that over 2a. All right, so that's what we're going to use. So let's start inserting our values in for our different variables, and we'll solve this. So my negative b then would be negative 8 this time, and then I'm going to have plus or minus the square root of 8 squared minus 4 times. So a here is going to be 1, and then c is going to be 15. And then all of that's going to be over 2 times 1. All right, so now I get to my next step then. So 8 squared is going to be 64 minus, so 4 times 15, because 4 times 1 is 4, so 4 times 15 is going to give me 60. And then all of that's going to be over 2 times 1, which is 2. All right. Okay, so I think we're all pretty much familiar with the square root of 4, which is going to be 2. So now we know that I have two equations. I'm going to have here the first one, which is going to be the negative, oops, forgot my fraction. It's going to be the negative 8 plus the square root of 4, which is 2, divided by 2. Okay, so that's going to be my first equation. And that one's going to equal negative 8 plus 2 is going to be a negative 6. And negative 6 divided by 2 equals negative 3. Okay, so then my other equation is going to be negative 8 minus 2, because remember we're plus or minus that square root of 4 over 2, which is going to equal a negative 8 minus 2 is going to be negative 10 divided by 2 equals negative 5. So therefore my two answers here, or my solution set, is going to be negative 5 comma negative 3. So those are the two zeros of my function. And if I wanted to go to Desmos and graph this, I would see that y equals x squared plus 8x plus 15. Enter. And so my answers then are going to be negative 5 and negative 3. So let me zoom in a little bit. Okay. If I zoom in, I can see right here, there's my answers, negative 5 and negative 3. Okay. There's my answers. And this here is going to be a minimum. All right, so the next one I have is going to be an x squared plus 5x plus 3, and all of that equals 0, because I'm trying to find the zeros of my function. Okay, so I'll do the same thing, and I'm going to insert the equation, and I'm going to use the negative b plus or minus square root of b squared minus 4ac, and all that's going to be over 2a. All right, so let's go ahead and just start substituting some values in here. So my b value is 5, so that's going to be a negative 5. I forgot my fraction. So it's going to be negative 5. And then right up here is going to be plus or minus the square root of negative 5 squared minus 4 times 1 times 3. And then all of that's going to be divided by 2 times 1. All that over 2a. Oh, wait, how did that get up there? That's not where I wanted that. Right, down here. All right, so again, what I've got here is the square root of 13. So on my calculator, if I find the square root of 13, that's 3.605. And I said we go ahead and round to the hundredth for this exercise. So that means I'm going to have my two equations again. So I'm going to have negative 5 plus 3.61 divided by 2, which is going to equal a negative 0.695. And then negative 5 minus 3. Whoops. So negative 5 minus 3.61 is going to be a negative 8.61 divided by 2, which gives me negative 4.31. All right, so those are my two answers. And again, if I were to take this and come over here and graph it. Here's my answer. So I said one of them was, now we rounded slightly different, so our numbers might be a little bit different, but there's one of my x-intercepts, and there's my other. Okay, so again, I want you working these out with the formula. Don't just go to Desmos and do it, because you need to learn multiple representations for math. So you need to learn how to represent things in graphs, words, and algebraically in equations. So you need to learn all of them. All right, so that's how you do it. And if you need more help, come and meet me on Google Meet, and I can give you more assistance with the last two. All right, so have a good day. That's all.